Good afternoon, everyone. Myself, Dharmin M. Patel, Assistant Professor in Mechanical Engineering Department, RNGPIT Bardoli. Heartily welcomes you all for this wonderful knowledge sharing webinar series. Today with us, Dr. K.B. Rathod sir, Head of the Mechanical Engineering Department, RNGPIT Bardoli, and Mr. N. Rathod sir, Assistant Professor in Mechanical Engineering Department, RNGPIT Bardoli. And our expert, Professor Dr. Ganesh sir. He is a professor and associate head, School of Mechanical Engineering, Dr. Vishwanath, MIT World Peace University, Pune. Now I request to Dr. K.B. Rathod sir to say a few words about the webinar. Over to you, sir.
Thank you, Dharmin, and good afternoon to all the viewers. Myself, K.B. Rathod, Head of Mechanical Engineering Department from RNG Patel Institute of Technology, Bardoli. Heartily welcomes you all on the 44th webinar of the Mechanical Engineering Department and 142nd webinar of the college under SSIP cell. The topic of today's webinar is Advancement in CAD, CAM and CAE. And to present such an important technical topic, we have with us Professor Dr. Ganesh Kakandikar sir, who is a head and professor at School of Mechanical Engineering at MIT Pune. And to know more about him, I request Nirav Rathod, Professor Nirav Rathod, to say a few words about the sir. Over to you, Professor Nirav Rathod.
Thank you, K.B. Rathod, sir. I am Nirav Rathod, Assistant Professor, Mechanical Engineering Department. Good afternoon, all of the viewers. I invite you all for the today's webinar on Advancement in CAD, CAM, CAE. Let me introduce our today's expert, Professor Dr. G.M. Kakandikar, sir. Professor Ganesh Kakandikar, sir, is Professor and Associate Head at School of Mechanical Engineering, Dr. Vishwanath Karar, MIT, World Peace University, Pune. He has 20 plus years of experience in this field. Sir has presented plenty of research papers in presented as well as published research papers in various peer journals. Sir has received a research grant of rupees 15 lakhs from Aeronautical Research and Development Board, DRDO, New Delhi, for his research in aerospace field. Sir has received research grant from Scientific and Engineering Research Board at Zurich, Switzerland. Sir has received national level third prize for research on microforming at IMTEX 2020, organized by Indian Machine Tool Manufacturers Organization, Bangalore. So, sir has wide experience in the field of CAD, CAM, CAE. So, it is matter of pride to have you as our expert for today's session. Thank you, sir. Over to you, sir. Kakandikar, sir, please.
Good afternoon, friends and viewers. Indeed, it is a great opportunity to interact with all of you on a very new topic that what all mechanical engineers should now concentrate upon for their careers, their research work, and which is CAD CAM CAE. At the outset, I would like to thank on behalf of my institute and university to the management of RNG Patel Institute of Technology, Honorable Principal Dr. Chaudhary, Honorable Head of Department Dr. Rathod, for giving us the opportunity to interact with all these students. So now let us start talking about the CAD CAM CAE. I hope you heard about the CAD CAM CAE, which is computer aided designing, computer aided manufacturing, and computer aided engineering. Way back 20 years back, we started shifting computerizing all our machines and operations into manufacturing sector. And slowly now we have converted to all these areas. So now mostly in any organization, any manufacturing organization, on any shop floor, we do not have any activity that basically takes manually. Now it is all computer aided. Whatever may be the activity, it is computer aided activity only. Is it sufficient to have knowledge of that? No, it is not sufficient. See, the technology is changing like anything. and the change that is happening, the pace of change of technology is very high. Even in mechanical engineering now, which was basically related to computer engineering and electronics engineering. So initially our technologies were going to change after 10 years, 20 years down the line. And now the technology is changing within 1 year, 2 year, and we are adopting so many things. So in this today's class, we will try to explore what are the things that are coming in mechanical engineering and with the aspects of CAD CAM CAE and what the graduating engineers should learn, should concentrate upon. And they should know these are the new areas where there is no human power is available for working, sparing. And if they get specialized into these areas, they are going to have very good jobs. And what it is said that what is constant, change is always constant. Nothing is constant, change is constant. So we mechanical engineers now, this is the era, this is the time to understand that we also need to have managed the change. So we must learn change management. And basically CAD CAM CAE operates with the change management because new and new platforms, new and new technologies are coming down, and then we have to grasp them, we have to learn them. Immediately we have to shift from one technology to another technology. And we should not have any hesitation to do that. We should have our self-learning experience to do that. And we should be capable of doing that and also capable to handle the change. Now I will, through this my 1 hour's lecture, I will take you through major 3-4 sectors of CAD CAM CAE, what we want to work with, we should work with, because conventionally mechanical engineers have done different jobs, but now this is the time to change the perspective, thinking, and research attitude also. And then at the end, I will try to give 10 minutes to introduce my university as well as few good courses what we are running, and the specialization whatever is available if anyone is interested to do that. Now let us move on to the first topic of interest, which is called as product life cycle. Friends, we have seen that we are the mechanical engineers who design the products, who manufacture the products, as well as who sell the products into the market. And now you can see that when we manufacture the product, when you design the product, a product is going to work on the shop floor for a certain amount of time, and then it will elapse, it will go away. Let us take an example to understand this concept. 20 years back, Bajaj scooters was very famous in India. Few of the cities like Pune, it was called as a city of scooters only. So now to understand these concepts, when Bajaj came up with these scooters, which has this two-stroke engine technology, they run on the shop floor for almost 20 years. And now you could find that there is no Bajaj scooter available. 10 years back, only Bajaj stopped their production. So why it has happened? It has happened because some new technology came into the market, which have replaced the old technology on which the product was working, and the product has died from the market. But let us try to understand that whenever any new product come into the market, how it works into the market, and then what is the role of mechanical engineer right now to work on that. If you see this graph, what I have plotted, on x-axis there is a time, and on y-axis this is sales. This is a very familiar concept. This is popular concept which is called as product life cycle. And then this curve goes like this. The complete life of a product can be divided into 4 major stages. One is introduction, one is growth, the third one is maturity, and fourth one is decline. Why did decline happens? Decline happens because some new technology will came and it will replace the old one. So now nobody would be ready to accept the product which is working on the old technology. Let us take an example. Now we had all Android machines, Android phones. So nobody would like to go for Windows phone because that technology has been replaced right now. Now, if you plot this graph, because ultimately being the engineers, we are working into the organizations to design, develop, manufacture, sell the products so that we can earn the profit. So what is more important is that whatever you design, it should be accepted by the customers. It should be accepted by the market, and the market should be ready to exchange a commodity. They should be able to purchase our products by giving the price what we have fixed. Now, if you plot this graph between the cells, that how many components have been sold over the time period, you could see that initially in introduction phase, only few components have been sold because the product is new, technology is new, people are hesitating to buy it. They don't want to buy it because they don't know whether the product is good or bad. And then once few people, those who are called as early purchasers, they will purchase, they will experience, they will talk on that. Then other peoples will start following them, and then in the growth period you can see that there is a highest amount of rise in the sales of the product. Once you finish with the growth, then the stage comes which is called as maturity. In maturity, now the technology has been stabilized. In growth phase, people are working on technology. They are trying to improvise the performance of the product. They are trying to reduce the price so that they can reach to many people. They are trying to go to the global level. So in maturity stage, now the technology has been matured quite well. So there are no much changes that are going to happen into the technology. What they need to concentrate upon is the after sales service. Those people, those who are using your product, they should be happy, and the product should work satisfactorily for the designated life, what we call as reliability. So if I purchased a washing machine, it should work satisfactorily for 10 years. Now, what happens during this period, because this time period, introduction, growth, maturity, if you measure in terms of years, it will be different for different products. If you take an example right now, what I talked about Bajaj scooters, this would have been almost 15 years. And now if you talk about mobile technology, and if you talk about one system, one Android system or one operating system, it would be few months also. Because we know that now we are continuously modifying, changing the operating systems, which are changing every 6 months. So within that 6 months, it is introduced in the market, it is grown in the market, and it got to the maturity. After 6 months, 8 months, new technology will come, and the old technology will be replaced. Why we need to understand this? We need to understand this because conventionally, being mechanical engineers, we have worked in a situation which is called as compartments, compartment zones. Like design department was working very isolated. Design department was supposed to be the supreme department. They were not used to disclose anything what they are designing to the manufacturing people and to the other people, because design is supposed to be not disclosed, because someone can copy it and the competitor can go with the same design. But what has happened due to that, we were working in compartments. So when the data came to the manufacturing people have a lot of problems, and then they will modify the product with respect to the manufacturing facilities they had. Within this time, you are supposed to lose a high amount of time. Right now, it is not possible because each and every product which is manufactured is globally distributed. So it is designed at somewhere, it is manufacturing at somewhere, and it is distributed throughout the world, what we call as concurrent engineering, and now we call it as a collaborative engineering. So now it is not easy to spare this time in unwanted activities. We don't want, because we don't have time. Previously, to design, develop, and introduce a new car for car manufacturers in the country was 5 years. And now it is hardly 8 to 10 months. So you can't waste any time on these activities, and you have to shift from traditional approach to the concurrent engineering approach. And now by using the information technology, we call it as a collaborative approach. Now let us try to understand what mechanical engineers plays a role here and how it works. If you see in manufacturing scenario, we are the people, those who are working. We are the engineers, we are the manpower, those who are working. So people are working in manufacturing, sales, customer service, marketing, design, engineering, supply. All the departments people are working, and those are expertise. We work on certain processes. We develop processes. We realize processes. We use processes. We define and conceive new processes. So we work with certain standardized processes. We have standard operating procedures. Then there are tools, lot of tools we using. Conventionally, we were using different tools. Now we use lot of tools, computer-aided engineering, computer-aided designing, computer-aided process planning, requirement management, lot many things. And the new tools, those are coming. These tools are basically part and parcel of CAD CAM CAE, what we are trying to understand right now. Now, there are a lot of methods. We have philosophies on which we are working. I told you one philosophy, conventional methodology, working in compartments. Then that came as concurrent engineering. People used to sit on a round table and used to discuss each and everything. So this conference used to have one person from design, one from manufacturing, one from purchase, one from marketing, one from sales. They used to exchange their ideas so that when the design is finalized, it is finalized in consent with everyone, so that there won't be any changes people have to arrive at when the manufacturing starts. and there won't be any delay in manufacturing. So we are working with such different methods, and we are working on certain technologies. Now we all working on CAX. What is CAX? CA represents computer aided, X represent anything. So now you can have CAD, CAM, CAE, CAPP, CAQC. Lot many technologies are there on which we are working, and predominantly this black box, a computer or laptop, has become the essential part of working of a mechanical engineer over the time. And if you see at the center, what there is a data, lot of data. What data we do handle? We do handle data of geometry, because we are designers, engineers. So we present all our product in terms of drawings, and now we present all our products in terms of solid models. We present structures, how my product is constructed upon, what is the assembly, what is the base part, how the parts are assembled, what assembling techniques are required, what fixtures are required, what the nuts, bolts, screwdrivers, the supporting parts, they are required, what type of fixing it is, whether it is permanent fixing, whether it is semi-permanent fixing, or whether it is temporary fixing. And each and every person working into the organization is generating the data each and every minute. So at the center of all these activities, what we are doing right now is the data, and we need to understand the importance of this data. I will ask you a simple question. Now, if you had a laptop, you had a mobile phone right now, you are working on mails now. If somebody asks you immediately, do you know where is your recent bio data? Whether it is on your mail, whether it is on your computer, whether it is on a laptop or mobile, probably you will not be able to find out which is the latest version and on which device you had. The same thing was happening in industries. The same thing was happening in industries, that we have data which is distributed at different places, data being handled by different people, data being manufactured, and data being modified by different people, data being accessed by different people. And now we need to understand that when you talk about product life cycle, what we discussed on last, if you want to manage it, so each and every activity that happens starting from the scratch of the concept to the manufacturing to the selling of the product in the market, reliable working of the product for designated life, and then ending of the product when it has died. Each and every activity involved during this timeline is called as product lifecycle management. So what product lifecycle management does? Product lifecycle management basically people with processes, processes with tools, tools with methods, methods with technologies, and technologies with data. So whatever activity is being done by each and every person concerned into this perspective on this canvas, it is recorded at a centralized database. And initially what I talked about, conventional approach, where we are working in compartment wise, so data was stored manually and in compartment. Now the data is being stored at central level. Only one data is being stored, and that same data has been given authority to different people to use, to open, to see, to modify, to approve. And not only we have data, we also have metadata. What is metadata? Metadata is basically data of data. See, if you had your hard drive and you had your project onto that and a lot of things onto that, so you say that I have a lot of data on my laptop, on my hard drive. But when you go to your hard drive and say D drive, you right click and you say properties, it will give you the information about the data, that you have say 100 folders, 200 files, and the total memory is this, available memory is this, something like that. This is called as metadata. Data of data is called as metadata. Try to understand an organization, suppose like Tata Motors, which is manufacturing 8 to 10 different cars, or maybe Maruti Suzuki manufacturing 8 to 10 different cars. Every car is available in petrol version, every car is available in diesel version, and every car has 3, 4, 5 variants, basic, middle, higher one. So if you see the total portfolio of them, 10 cars, 3 versions goes to 30. It means they are manufacturing actually 30 different products. Can you imagine for a car how many components would be there to assemble a car? Thousands of components are there. Every component is somewhere being designed. It is being manufactured either at the own place, either it is being purchased from vendors. So can you imagine what enormous amount of data we are handling every day? And now this data is continuously updating, continuously changing. So this is called as vibrant data. So suppose on one machine, somebody started manufacturing turning operations, a simple component. Once he finishes first component, data is being modified. Once he finishes second component, data is updated. Now 2 components have been manufactured. So each and every person who is working in the perspective of manufacturing is generating enormous amount of data. My next question is, where are the people to handle this? Who are the people to handle this? So yes, we need specialized people with CAD, CAM, CAE knowledge who can sit in an office and they can only manage and handle the data, and they should make this data available to everyone so that everyone in the organization should have recent data. Can you imagine if for few fraction of seconds the website of Indian Railway crashes? What will happen? There will be lot of duplicate allotments will be done with the passengers. And what will be the cost of that to the Indian Railways? That suppose one seat has been allotted to many people. No. So if you are sitting there in US and accessing website, if I'm sitting here in India accessing the website, or the person on the counter of Indian Railways who is accessing the website, it is giving you live status, live data, recent data, so that everyone can take the decision whether they would like to buy a ticket or not. We want to give the same information to the mechanical engineers on the shop floor that this is the recent data, and with this data you have to work. So you need not to work upon the old data, because in conventional approach, what has happened, I talked about change management, that somebody has been designing something from design department and it is given to the manufacturing, and manufacturing people will come back saying that, okay, these are the features, these are not possible, we don't have any specialized machine here, so can you change this? So design people will do some change, okay, and then this is called as ECR, engineering change requirement. So design people will modify the design slightly, will remove that profile, send it back to the manufacturing. Because the concern was raised by manufacturing, other departments, they have received the earlier design and they have started already working on the earlier design. Probably they don't have any problem. But now actually the design has been changed. And now this new design will be again circulated to all the departments. By the time they come to know the design has been modified, upgraded, they have already wasted a lot of time in the old design. So in manufacturing, we need to understand that we have to minimize these changes that occurs once the design is released. And if you want to minimize these changes, we should work upon the data at centralized place. Now we have people in manufacturing, those are working in manufacturing, procurement, engineering, design, marketing, but we don't have people, those are mechanical engineers handling data at the central location. And then if you get expertise in CAD CAM CAE on database management, or the next concept that I am going to talk about, you can have good job opportunities in the industry because there are no people to work in. All our mechanical engineers have conventional knowledge only. Now let us move on to a corrected and connected concept that we talked about. I hope you heard about big data, and big data. Yes, big data is coming like anything in the market. And not only it is coming with computer engineering, not only it is coming with electronics engineering, it is coming with us also, manufacturing also, mechanical engineering also, like anything. What it is? Big data, it is nothing but it's a data in huge proportion, in huge quantity. Okay. Now let us take an example of Facebook. How many users the Facebook has throughout the world? Everyone is updating something, writing on Facebook, sharing something, downloading something, watching something. So Facebook is handling enormous amount of data of all their users. Similarly, say Amazon or other website also. Now, what I talk to you right now in manufacturing scenario, that everyone who works in manufacturing organization, every second, he's generating enormous amount of data. How we are going to ensure that the data is being properly handled, the data is being properly given, provided to each and every person, each and every stakeholder in the company. Now the stakeholders, when you talk about, there would be vendors on backside, because they are also using your data, because they are manufacturing few of the components for you only. And on front side there are users, so users are also accessing your data. So if a user want to know how the car looks like, and if a user want to know what would be the dimensions of the car and what are the specifications of the car, you are providing them data, and so many users are interacting with your company. Now, if you see that the companies like Google, eBay, LinkedIn, Facebook, they first identify that they need to handle such enormous amount of data, and the concept of big data came into the market. Now, the new information technologies with which we are now working, just like now when I connected to you, we are working with information technology only. So big data can help us in handling this enormous amount of data, which will result in cost reductions. It will also help us to do substantial improvements in the time, and also our computing tasks will be easy. It will take less time, it will take less investment, and that's why we can design, develop, manufacture new and new products, new and new service within less amount of time. We can reach to the mass customers on the globe. So we also need, as a mechanical engineer, when you learn product lifecycle management, you also need to understand what is big data, and this big data, how it is concerned with my mechanical engineering and with my manufacturing engineering, and what would be the role of mechanical engineer now, today and tomorrow in handling this data. So let us try to define big data. Big data is nothing, it is similar to small data, but it is bigger in size. It is bigger in size. Every moment, every second, the data is being changed, the data is being updated. So you need to handle enormous amount of data, large amount of data, and we need people, those who are specialized in handling this data properly. Now, when you say we are handling, means storing the data, recording the data, dividing the data into different types, giving access to different people, giving authorities to different people to handle the data, and then providing the access to the data in fraction of seconds. We also need to design and develop the systems which will give us, like, say if you are seeing a video on YouTube, and if it takes time for streaming, you won't see it, you don't want to wait. Okay, and you have seen that on Google. Suppose if you search something on Google, that is automatically connected now to Facebook. So next time when you go to Facebook, similar advertisement will be displayed to you. What Google is doing, what Facebook is doing, they are studying their customers, they are studying their users, they are studying the patterns of the customers, they are studying the likings of the customers. And see, when I am working, if and today if I searched about a hotel in Pune, it means I want to go for hoteling. So next time when I log into Facebook, Facebook is giving me only advertisement related to hoteling. They are earning a lot of money based on these advertisements, because they know my preference, what is my mood today, what I would like to do. Or say suppose if I searched that I want to purchase Apple laptop, next time when I visit Facebook, they are displaying me the laptops only. So they are recording my choices, they are recording my preferences. So they are trying to understand their customers, their preferences, their likings, their choices. And can you imagine for one person what would be different likings when he surfs on internet, on Google, and what amount of data Google is storing and displaying for you, customizing the preferences and only displaying that preferences to you. What amount of data Facebook is handling when it has billions of users throughout the world. What we need as a mechanical engineer, we also have the same data. We have thousands of design production drawings, then solid models, assembly drawings, we have list of materials, bill of materials, each and every, if you just take one simple part, a bolt that is used, so bolt has been designed, modified, defined, being manufactured at our place, or given order given to some vendor is supplying in say quantities, then vendor has dispatched the quantity received at inventory, it is checked, inspection done, the lot is good, it is stored, it is started utilizing. At each and every event, data is being modified, and we should know what is the latest stage of data. This simply looks like that. Suppose if you order something on Flipkart, so they will give you a message that okay, your order is received. After some time they will say that okay, your order has been packed. After some time they will say that okay, your order has been dispatched, your order has arrived to your city, your order is out for delivery. Okay, so what they are doing with every event, what they have already defined, they are trying to update you. And with every event, lot amount of data has been generated and they are handling it properly. The same thing we were not doing in manufacturing, but now yes, it is the right time. If you want to be competitive in the world, if you want your product to be of that approach, you should learn new techniques, new tools, and new architectures for data handling. And there are no people to work into this area also of big data. As there are no people to work on integration of all the facilities in PLM, there are no people to work in these techniques also, which is called as big data. And big data is manufacturing is going to do like anything. Also, it will open the door like a new field which is called as medical science, healthcare. How many hospitals we had right now in India? Now we are struggling with COVID. So many hospitals, so many patients, every patient has a history, he has taken some medicines, lot of tests has been done. So if you want to record this data, enormous amount of data for each and every patient, and this data is to be stored permanently, because next time, say after 2 years, you go back to the hospital and say that okay, you had some different complaint, they should know your history. Can you imagine what enormous amount of data is being generated is being generated in healthcare? And then we need to understand that how we are going to achieve the data, how we are going to arrive at the data. Now we also want to see that the companies like Walmart, they handle lot amount of data, like they might have billions of customers. Facebook handles lot of data. Similarly, we have lot of components, thousands of components, and we need to understand that these components have their own specifications, designs, bill of materials, material has been changed, material has been designed over the time period. So many things are there which happens, and we need to understand that how we are going to design, develop, and have these data. Now if you want to see what are the properties of this data, that what we are trying to understand, one is the volume, how much amount of data you are trying to understand. Okay, the another thing, what is the velocity, with which speed you can store the data, and with which speed you can access the data. That is more important. As I said, that if you are accessing the data and suppose it takes a lot of time, nobody would be interested to work with your system. Similarly, the variety of the data, what different types of data is there. And in manufacturing, if you see, we have different type of data available. So data is about designs, data is about specifications, data is about materials, data is all about material properties. So there is lot of variety. Data is about purchase orders, data is about quality control, data is about inventory, data is about the things that are going on shop floor, data is about machines, their working conditions, data is about maintenance of the machines, data is about the people, those who are working on the shop floors, data is about officers, data is about total number of components manufactured, failures, breakdowns. Enormous amount of data is there. So there is a lot of variety in the data. That is what we are generating. So we must understand that our data in manufacturing has a lot of volume, it has velocity required. So we must have supporting systems which will allow us to handle this data and also to handle the variety of data. And if you see some general examples, mobile devices, readers, scanners, microphones, cameras, they handle a lot of data. Similarly, now we need to understand that on shop floor in manufacturing organization sector, we are handling a lot of amount of data, but there are no people, expertise people to work on these areas. Companies are shifting from manual handling of data to computerized handling of data, and we are slowly converting from the small data to the big data. And we could say that these could be the coming field: manufacturing, as I said, smart healthcare, I already talked about, and also the search quality, though it is not required with mechanical engineers, but if a mechanical engineer got expertise into that, he can work into all these areas where he has to handle the data. The third thing that is coming in mechanical engineering, which plays a very important role, what we call as, is artificial intelligence. We have seen that now with the COVID, it is difficult for even doctors and nurses to go in contact with the patients. It is very risky. And then few of the hospitals, they employed the robots to work with these patients so that there would not be any spread of infections. So now we need to think that we have to design and develop such machines which will have artificial intelligence. So we are going to imbibe a natural intelligence, just like a human being, into the artificial machines, what we call as robots or humanoids, okay, or now we only call as bots, and so many things are coming. Let us try to understand what is artificial intelligence, because not only in the robots, we are going to add this artificial intelligence into our machines also, with which we are working. Similarly, like our car, they had their own artificial intelligence now. If you talk about artificial intelligence, it is nothing but the study of computer systems that will attempt to model and apply the intelligence of the human mind to the artificial systems. And for being mechanical engineer, for me, artificial system is nothing but my machine. So whatever may be the name of the machine, it is my machine. So what I'm trying to do, I'm trying to build a machine with a capability that it will imitate, it will copy the same intelligent behavior as a person would do. So it will take the same decision in the situation what the person would have taken with the data provided to these systems. If you heard about these things, Google Now or Siri on MacBook or Cortana on Windows, these are assistants and these are intelligent assistants. So if you ask anything to them, they will easily ask you if you are connected with your internet. If you are connected with the internet, same type of techniques can be add into manufacturing. Say, suppose if a worker is working on a machine and if has a problem, why he should call to a maintenance people, and he should just call a Siri or Cortana or a health assistant which is available on the machine and ask that, okay, my machine spindle has stopped, what should be the first thing that I should do now? Then this assistant will tell him, okay, the first thing is that you switch off the machine and please check these three parameters of the spindle. If it is okay, now then you check the next thing. So this personal assistant, intelligent assistant, will assist you to identify, to rectify the problems, and at the same time it will give you a lot of information to solve the problems. And now these systems we are already using related to information technology, but in manufacturing we need to do this. So if I'm designing a robot, if I'm designing a machine, if I'm designing a conveyor, if I'm designing a machine which is controlled by multiple machines, which is connected with multiple machines, my machine should be intelligent. So if the machine identifies that anything on the machining process is going wrong, it should immediately stop the machine. First thing, it will indicate of breakdown prior it actually breakdowns. It should shut down itself for safety purposes. So I need to inbuild artificial intelligence into my machines with which I'm working. And if you go back and would like to trace the history of the artificial intelligence, way back in 1950s, the English mathematician Alan Turing, he basically write first time an article, Computing Machinery and Intelligence. Okay, and then people started thinking that can a machine can think, can machine can have logic, and can the machine take a decision? And then slowly the field of artificial intelligence has developed like anything. So now we are manufacturing the machines. So what are the probabilities of the mechanical engineers to work here? Yes, there are a lot of probabilities of mechanical engineers to work here, in which on the backside when you are designing and developing a machine, we need a lot of people who understand AI, so that we can add AI to all our existing machines. And the second thing is that on front side, when you are using a machine which has AI, okay, so how to use it, how to operate it, and how to handle it. Friends, if you see car that is being manufactured by Mercedes-Benz right now, it has more than 100 sensors right now. Because traditionally we used to say that car is a mechanical engineering product. It's our domain. But can you imagine it has more than 100 microprocessors which are working on artificial intelligence. So most of the decisions are taken by car. Or maybe a flight which was said to be the aerospace engineering component. Now when you say that it is on autopilot mode, okay, it is taking all intelligent decisions. If and if required, the pilot is going to interfere into that and he will take the manual control. What does it mean? It means that yes, we are interacting with the other fields of engineering like computer engineering, electronics engineering, electrical engineering. We cannot make ourselves segregated, separate, in vacuum with all other engineering streams. So we must also understand these streams, importance of the integration of these streams with mechanical engineering. And now you can see that as you say that car is our product, electronics people will also say that the car is their product, and also computer people also will say that car is their product, because the car takes a lot of intelligent decisions right now. So there could be a lot of general applications what I listed here, but as far as mechanical engineering is concerned, we need people in design and development of machines with artificial intelligence. We need to think of what artificial intelligence should be added into my machine, and then how that would be added, what design you need to change into that machine. Now with the coming electric vehicles, you know, the total design of a car has been changed drastically. Initially when my car was working with SI engines, the design was different, and now when my car is working with say electric uh, systems, the design of my car is very different. So I need to understand that if I am going to add AI into my machines, what design is going to change, what new perspectives I can add, what new offers I can add into the systems, and what benefits, what new facilities it will offer to my customers so that customers will take. On the front side, there should be a lot of people, those are needed to handle these intelligent systems. So they should also know how to work with the systems, how to cope up with the systems, and their maintenance, their carrying capacities, their modifying capacities, applications at new and new places, different places for innovative applications. We need a lot of mechanical engineers should tune down to the artificial intelligence. They should learn. You see, there is an unending future for artificial intelligence. Now, I talked about a car which has 40 sensors, but now we are talking about uh, self-driving cars. So you need not a driver also. You just sit in, start the car, and as I said that a flight on autopilot mode, similarly, car will run. It will take all intelligent decisions. Similarly, we may have systems which we are going to build for medical care and treatment. Because see, if the application is different, but if you're building a system, if you are designing a robot or if you're designing a system, whatever it is called, if it is a machine, yes, mechanical engineer has to design it and he has to add that artificial intelligence into that. So we need to understand that lot of people are required into the artificial intelligence area. There is one more sub branch of AI which is coming up, which is called as machine learning. I would not go into the details of the positive points and negative points of the artificial intelligence. You can just go through. But yes, there are a lot of positive points, and as every technology has certain negative points, limitations, this technology also will have some negative points. Now, if you want to work with AI, you should also learn different techniques which are categorized under AI. So it could be machine learning, it could be artificial intelligence, it could be neural networks, or it could be bio-inspired optimization techniques, and so many things. What is machine learning? Basically, machine learning, it talks about a smaller field or a subfield of artificial intelligence. And the name has been given to it considering that this field, this area, this specialization will deal with construction of the systems which can learn from the data. It can learn from the data. Say suppose if I have a data of 100 patients given to a system. So system will only store the data. I am the person who is going to divide it. How many patients in the age of 0 to 10, 10 to 20, 20 to 30, likewise that. I need to decide. I need to decide how many patients are of, say, typhoid, how many patients are of ulcer, how many patients are of, say, um, heart patients. So I'm the person who is trying to analyze the data based on different factors. But suppose if I have machine learning, I am going to only give that data to machine learning. Based on that data, the machine learning will automatically study the data and it will work on that data and devise a new system. So that next time similar data is given to the system, it will automatically devise the data, process the data, and will give me output from that. Okay, so it is nothing but a just building block that will help the computers to learn from the data more intelligently, to understand the data more intelligently, to handle the data more intelligently, to process the data more intelligently, and to give the outcomes or outputs more intelligently. So machine learning also is coming like anything in mechanical engineering also, because we want this machine learning to be added into all our machines. So if you want to define it, what is machine learning? Machine learning is nothing but a computer program that is said to learn from experiences with some class of tasks and a performance measure. So this class of task is nothing but the data that is being provided, and performance measure is nothing but the output. Like, say, in this condition, a chief minister of a state or maybe prime minister would like to understand how many patients of COVID are there right now at this moment, how many have died, how many are serious, etc. What we do is that we collect this data at each and every part. It is gathered at certain places. So taluka wise, then district wise, state wise, and then it is given to the prime minister's office. Can we have a machine learning algorithm which will automatically find out this data from the computers which are running into the hospitals, where the entry of each and every data has been done already by the people? So might it be a government hospital, or might it could be a private hospital. If it is connected on LAN, internet, the machine learning can automatically gather the data, and not only gather the data, it can give you minute to minute updates, addition of new patient, or maybe release of one old patient. Each and everything will be done by the machine learning only. There are no people to working into these. Why we want to handle the data? What we want to do with the data actually? So we want to extract the features by taking some samples, and then we would like to come to some conclusions, so that based on that conclusions we can take some decisions. What are features? Features are the distinct traits that can be used to define, describe the quantity in a quantitative manner, or any item, any product in a quantitative manner. Let us move on to the next slide, and this will give you an idea. If I say what is apple, so for me, you and somebody other, apple would have a common definition that it's a fruit. But if you are a now AI engineer, if you are a machine learning engineer, for you, apple means something different. What means? It means one, color, either it is reddish or red. The type, it is a fruit. The shape, it is, okay, when it would be available, what time duration it would be available, what is the weight of the piece, okay, what is the cost of the piece. If you see, all these are features. Now let us move on. And when you say talk about this feature, this is also an apple. So here the feature has changed. So color, sky blue. Type, it was a fruit, it is a logo now. Okay. Shape, it has different shape, this is different shape. Okay, it has different cost, this is different cost. This is available for a certain amount of time in a year, this is available throughout the year, because it's just a picture logo. And there could be another apple, okay, which is yellow, which is found in some other different countries. It is again fruit, its shape is different, its taste is different, color is different, size is different, weight is different. So if I'm adding all these features like color, type, shape, okay, these are features. So when I have some data, my data also has these features. I need to recognize these features, and I need to find out these features for given data piece. I need to record it, I need to handle it, and based on that, I need to come to certain conclusions. And these conclusions will provide my organization foundation for taking certain decisions. Foundation for taking certain decisions. Now, if now a pharmaceutical industry would like to understand how many in India are ready to take vaccine for COVID-19? The answer is very simple: 130 crores, and not only 130 crores, billions over the globe. But now, if a car manufacturer would like to understand within this situation how many people would be able to purchase their car. Okay, now this data would be very different. So as an engineer, when we are working on manufacturing, we also generate a lot of data, and that data also has features. When you talk about one product, what is the name of the product, what is the code of the product, what is the size of the product, what is shape of the product, what is the material of the product, what is the use of the product, whether it is single use, whether it can be used in only one product or whether it is used in so many products, what is the material, what manufacturing processes are required, what is the function of the product. Try to understand. Enormous amount of data can be generated for each and every component that we design, manufacture, including very simple screw or some simple nut on an organization. Okay, and then we have some of the systems what we call as supervised learning, unsupervised learning, semi-supervised learning, as well as reinforcement learning. So these are types of machine learning. Basically, you can apply any one technique based on the data and the type of the data that you are handling, and then you can identify this. So there are some techniques also like classification, clustering, meaningful groups, regression. So based on that data and what you would like to work with data, what exactly you would like to do with the data, you can select an appropriate technique and then you can work with this technique. There could be enormous applications. As I told you, I'm only concentrating upon the data related to mechanical engineering, manufacturing, or purchase or inventory control. Yes, there are a lot of opportunities available in others also, like clustering, medical translation, healthcare, etc., etc. The next field that I'm going to talk about, virtual reality and augmented reality. These are the new fields, though these are coming into mechanical engineering also, and we are not untouched. Right now, we are working on softwares and we create models, we assemble them, and we try to understand how they work when CAE analysis also. But now, when I work, I only work on a virtual environment. So what I do when I work on a software and create an assembly of, say, jack, okay, I create a virtual world that is called as virtual reality. So there, each and everything is virtual. Nothing is real. It only looks like real. And there, I'm trying to understand because I'm creating that virtual world looking towards actual world. So I'm basically mimicking, basically copying, basically designing the real world on a virtual platform. Now, this has also certain problems when we work with virtual reality. So now the trend is coming of augmented reality. What we call as augmented reality will superimpose, basically, it will superimpose the virtual reality on the actual reality. So what I can do is that I can take an engine, I can take the casing of the engine, which is real, and from on that casing of the engine, now I can create all inner parts on virtual environment, and I'm trying to match all inner parts how they will fit into an actual engine which is manufactured. So if you see augmented reality, I'm trying to superimpose virtually generated the inside component of the engine into a real engine casing, and I'm trying to understand how it works. So this is basically a combination of actual reality and virtual reality, which is called as augmented reality. And now when we are designing the product, we should add this augmented reality to our area, because the day will come we will work on AR as well as VR prior deciding any product, prior finalizing any product. I will give you a best example of AR VR. Uh, that if you go to basically a website which is called as lenscart.com, and suppose if you want to purchase some glasses, but you want to try them, so you have to go to a shop and then you have to take a lot of frames and try it which suits to your face. Now you can go to the Lenscart website and they have a module of augmented reality. So what they will ask you to take your photo from your laptop or mobile, and then your real photo will be augmented with the frames available, and there you can live see each and every frame to be fitted on your face and how exactly it looks like. So taking a real environment, superimposing a virtual environment into that, we see how they are integrating with each other, how they work with each other. The another example, there is a website which basically sells the sells the furniture. So if you had a room, and suppose if you'd like to take a sofa set, so you can take a picture of your room and upload onto the website, and the website will, you can select in any sofa set available onto the website, and you can, with augmented reality, you can try, it will give you a real look that when you place that sofa set into your room, how basically it will look like into your room, whether it will suit, whether it will not suit, whether dimensions would be appropriate or not. So these are some of the applications what I talked about in general sense, but in mechanical engineering, manufacturing engineering, we are going to have a lot many applications, because our product design is completely going to be now based on virtual reality and augmented reality. And if you want to work with this AR, VR, you need a head mount display. I hope everyone has seen that, some motion trackers, and some software in which you are going to programming. So we have a lot of softwares on which we are working for this also. The next field that is coming, which is called as basically modern optimization techniques. So when you want to design and develop, we have a lot of new techniques of optimization, because everyone wants a product at lower cost. Everyone wants a product with higher and higher facilities given to the customers, and that requires optimization of the systems. Optimization of the systems, we have new categories of the algorithms which have been designed, developed by few of the researchers over last 30-40 years, but this field has picked up like anything in last 5 years. And these are called as nature inspired algorithms, these are called as bio inspired algorithms, these are called as swarm intelligence, these are called as socially inspired, these are called as culturally inspired algorithms. I will just share with the paucity of the time, I will just share one example of this, and then I will move on to the some of the distinct features of my institution and the course that I would like to talk about you. So if you see, I could see a lot of birds flying. I could see a lot of birds flying, and you could see that they sit at one place immediately. They sit at one place, and immediately they will fly. They will go to another destination, and then again they will immediately fly. They will come down to some another destination. Can you close the door? They will come down to another destination. Have you ever imagined that how these birds are taking all these decisions? Now, being sophisticated and design developed system of aerospace engineering, we heard many times that there was an probable accident that could have happened because two flights came on same runway. We have a lot of intelligence systems we inbuilt it into aerospace engineering. There are people who are continuously helping the pilots to take the decisions. Still, many times it happens that two flights came on same runway. Have you imagined that? Have you heard sometimes that two birds, when they're flying, they collapsed with each other, there was an accident and they died? No. And we see that on road accidents, how many people are dying every day in our country, throughout the world, and it is being driven by so-called intelligent animal on the earth, a human being. So what is that natural intelligence God has given to these birds, maybe fishes, swarm bees, that they work with each other? Many times we see that there was a stampede in holy places, and many people died within that stampede. Or maybe we had some stampede last time in Mumbai on railway stations, local stations. Can you imagine honeybees when they are working with each other and collecting the honey from the flowers here and there and having network? Thousands of honeybees sitting at one place, how they are holding their weight so that anybody inside will not get damaged, hampered. What is that natural intelligence God has given to them that they can manage their weight management? Otherwise, it's not possible for a human being to lie similarly one upon other and do some creative work. And they are doing creative work. How do birds take decisions? How do fish take decisions? So based on that, some of the social scientists and then engineers designed, developed all these algorithms, which are basically inspired from the natural behavior of the natural behaviors of these birds, trees, or these different animals. And these algorithms are now applied in mechanical engineering or all the other features of engineering sciences to take the intelligent decisions. And this complete area is called as nature inspired algorithms. And we could have in manufacturing process optimization, design optimization, shape optimization, component design optimization, machining optimization, forming optimization. So this can be applied to so many fields in mechanical engineering. Now, this is all about what I would like to talk about 4 or 5 recent topics in the CAD CAM CAE, because these each and everything what I discussed is computer aided, and there are no people to work in. Now, it's my pleasure to introduce my university, Dr. Vishwanath MIT World Peace University, and previously it was known as MIT Pune. So it has been started long back with the vision of my founder, revered Professor Dr. Vishwanath Karad sir. And MIT is the first private institution started in the state of Maharashtra, and now it is being led by Honorable Rahul Karad, Executive President of MIT World Peace University. And MIT has been converted, given the status of state private university in 2017 by Government of Maharashtra. So this is the campus, which is centrally located in the city of Pune in Kothurud. So it's almost 20 acres campus, and my university has 8 different faculties, along with engineering, management, liberal arts, science, law, pharmacy, etc., etc. This is our legacy. We started long back in 1981, and now we have so many institutions in the state of Maharashtra as well as outside Maharashtra. The philosophy of MIT World Peace University is union of science and religion. We call it as a World Peace University. So an engineer or a professional should not be only good in professionals, but it should also be a human being, a good human being, a kind human being. So unless and until you unite the science as well as the religion and spirituality, you cannot be a good human being, you cannot be a good engineer. You know that Osama bin Laden was also an engineer, but he has used all his intelligence for worse things. So we don't want to do that. So all our saints, philosophers from India, from different parts of India, what they said, we are trying to implement that. And we work with 4 pillars: partnerships with industry, partnership with stakeholders. We work with social innovation. Yes, engineers are made for society, and we want to solve the problem of the society. We work with the research, and we also work with the new and new coming technologies. This is the leadership at MIT World Peace University. Honorable Dr. N.T. Rao is our Vice Chancellor, and this is the team. And these are our rankings, national level rankings done by different agencies. I will move on to the topic that I want to discuss with all these prospective students. That what technologies I heard about and I talked about. If you want to do specialization into that, if you want to learn that, my school offers 3 postgraduate specializations: design engineering, thermal engineering, as well as CAD CAM CAE. And what new technologies, what we listen now, get introduced with, they all are based on this CAD CAM CAE. So if anybody out of you is interested, they can contact my university. You can see our website, or they can contact me personally with your teachers, and I can help you to get specialized into that. Now let us move on to the specialization, CAD CAM CAE. So what you can learn into that, you can learn computer-aided engineering, computer-aided manufacturing, web-based engineering, automated manufacturing systems, biomechanics, mechanbiology, micro manufacturing processes, integrated product design and development, world-class manufacturing, design for X, customization of all CAD CAM CAE softwares, and so many things. And we have a credit-based choice system. It means a student is free to choose his own subjects and his own credits so that he can work upon. We also had 2 center of excellences. One is called as the Technology and Visualization Center, which we recently established in 2019, and we have all these softwares available as platforms available with us, and all these are industrial licenses. These are not academic licenses, these are our industrial licenses, And this center has been set up in association with Tata Technologies. So next 2 years, Tata Technologies is our partner, and they are going to train our students on these softwares with the industry perspective. We also have another center which is called a Center of Excellence in Advanced Manufacturing Engineering. So we have all these recent manufacturing facilities available with us, including 3 printers and a separate 3D printing lab or additive manufacturing lab. We have a lot of other research facilities available on the campus as far as mechanical engineering is concerned, like vibration meter, FFT analyzer, VR testing, 4-ball tester, then hydraulic circuits, pneumatic circuits, IC engines, computerized IC engines, then computerized UTM. So many facilities related to testing of mechanical engineering components and systems are available with us for that. These are the areas in which we are working, basically fault diagnosis, optimization of manufacturing processes, solar energy, CFD, biomechanics, and bioengineering. So a lot of things can be done in healthcare, design engineering, as well as metal forming and microforming, micro machining. These are our industrial partners for last 30 years. Our students are doing internships with them, and also our students are placed with all these. For master's program, if you like to we interact with industry also, these are some of the professors. Those are going to the industry and teaching, imparting training to the industry people. So we are not only graduating, we are not only guiding the students, we are also guiding the industries also here in Pune. We have good tie with that. The basic qualifications required for admission to these master's engineering, what I talked about, MTech Mechanical CAD CAM CAE, that you should have a gate score, non-zero gate score basically. If you don't have a gate score, we will have our postgraduate test around in second week of July, and those who don't have qualified or those who could not attempt gate, they can attempt PGPIT, like PG examination of my university, and they can come through that also. If anybody is having a qualified score as per the AICTE norms, AICTE stipend is available to them, as well as 6,000 rupees stipend for 12 months. For first 12 months is additionally available from MIT World Peace University for GATE qualified students, in addition to the AICTE stipend. And those who are below the qualified score, but they have more score than 5 of GATE, up to the qualified score, whatever it is for respective years, we also offer them stipend of 4,000 rupees and 5,000 rupees per month. We also provide them internships in the industry in Pune. We also provide them opportunities of internships in ARAI, Defense Institute in Pune. We also offer internships in a lot of industries in Pune, as well as IIT Mumbai also. Let me take this pleasure to introduce with one of my students who is presently right now working with me, Mr. Sanket Patel. He's from Surat, and he's presently working with me for his dissertation. He's about to complete now, and now he has done his final dissertation in IIT Mumbai Mechanical Engineering Department with Professor Mishra. So half of the dissertation he completed at my university, and last 6 months he completed at IIT Mumbai. So we provide these opportunities for the students, and he's a very brilliant student, and he completed almost 12 online certifications of different softwares from the software manufacturers itself, including ANSYS, Siemens, Altair, 3D software solutions, geometric solutions, Desai systems. Within 1 year, he has completed 12 different certifications. And all other students are also doing a lot of achievements and accolades to them. This is a very highly experienced team of the faculty members, those who are dealing with the people for postgraduate as well as PhD, because we also have a PhD research center. And we also, our faculty is working doing research. We have a lot of IPR available with also, and we also have a lot of funding. So in last 5 years, we have more than 90 lakh plus funding. And presently we are working on few projects, including myself. I'm working on a project of DRDO, ARDB, Aeronautics Research and Development Board of DRDO, which has headquarters at Delhi. I'm working on process called as microforming, and we are trying to analyzing the characteristics of microforming. We have completed so many projects, research projects. Our students are very brilliant, and they do a lot of activities. They are winners in all these competitions which undergraduate students basically take. We are the winners at India level in Baha, Supra, and as well as at US level. Every time our team goes to US, and they are the 4th in the world ranking wise. These are some of the perspectives of the students, what they expressed. And we have global alumni. More than 10,000 mechanical engineers passed out from MIT Pune since the first batch of which started at 1983 to till now. People are working in different organizations throughout the globe, and they are helping our juniors for their stakeholdings also. These are some of our distinguished alumni. I would like to only emphasize on one thing. If you heard about Tata Nano, because Tata Nano was manufactured in Gujarat in Sanand plant, the person who was the brain behind the Tata Nano, Mr. Girish Wagh, who was project in charge that time. Mr. Girish Wagh is our student and he has completed his BTech from MIT Pune. So he is our esteemed alumni who has converted that dream project of Mr. Ratan Tata into an actual product. And Tata Nano is now presently working very successfully on the shop floor. So this is all from my side. This is the campus tour. We have all other facilities available on the campus, including ground, auditorium, the curricular activities, extracurricular activities. Each and everything is available with us. So if anybody is interested, they can go, they can visit our website, they can be in touch with me. You can also contact your teachers. They can connect with me to you. So I thank once again to the management of RNG Patel Institute of Technology, Honorable Principal Dr. Chaudhary, Honorable Head Dr. Rathod, and all the faculty members for providing me the opportunity to interact with you and to talk upon a very latest emerging field. So I would request all my student friends, please be expertise into the field wherever you want to do it, but try to understand that these are the fields in mechanical engineering which will give you a good career. So this is the right time, identify it, get it trained from any source, whichever is available to you, which you can adopt, any university, and get it specialized into these areas and try to make a career into that areas, because these are the things, those are coming down the line 2 years, 4 years. So only thinking conventionally will not work out. We will have to change our minds. We will have to change our perspectives. Thank you. Thank you very much.
Thank you so much, sir. Sir, you have covered this so many aspects of the real advancements in CAD/CAM and CAE in this short duration. Now, I request Ms. R.R. Patel ma'am to ask some questions from the comment section. Over to you, ma'am, sir.
Yeah.
What do you mean by deep learning?
Pardon?
What do you mean by deep learning?
Your voice is not clear, ma'am.
Okay, just a second. What do you mean by deep learning?
Deep learning. See, deep learning is one of the type of machine learning basically. See, as I see that there are different strategies based on what type of data we are handling basically. So we need to understand when you select, say, supervised learning, unsupervised learning. Sometimes we need to feed data to the system wherein we need certain supervision. Prior, we teach to the system how to tackle with the data. Okay, we need to understand that what type of data we are handling with that. And deep learning is also one of the new field that is coming, which is again a subset of artificial intelligence of a machine learning, wherein we are trying to concentrate upon certain data and we want to go into detail. So it is one of the new field that is coming in the machine learning itself.
Okay, so one more question by, okay, what is the difference between machine learning and deep learning, or how is it related to one another?
See, as I said, in machine learning is fundamental aspect now. When you talk about machine learning, we talk about the machines to be intelligent so that they can learn from data. Now, the perspective with which they are learning would be different. In deep learning, it would be different. In supervised learning, it would be different. In unsupervised learning, it would be different. So, what the philosophy with which we are feeding the data to the system, and based on the data, how the system is learning, making intelligent decisions. Okay. So, this is what the basic difference.
Okay. One more question. What are your views on application of AI machine learning for country like ours, like India, which is still in developing phase? I mean, we are struggling with the basic needs and infrastructure. So, what are your views on it?
See, there are a lot of applications available to us like a country in India. Now we say that we are talking so much about banning China and the products those who are coming from China. The first thing that comes to our mind is that why we were buying from China, because these people made some inventions. They give us a lot of innovative products basically at very lower cost because their manpower cost is very low. Can we innovate such new processes? Can we design develop these new products which are available with us? So all these techniques what I talked about CAD CAM CAE, because if you see initially when we were designing a car it takes 5 years. Now we can design a car in 8 months, and it was only possible by CAD CAM CAE techniques. Okay. So similarly, if you apply all these techniques into the manufacturing scenario, definitely we can come up with lot many new products available within less time, having lot many facilities with low cost, with newer and new materials, and which will be given, applied to a variety of customers. So yes, we have a lot of probability, and by virtue of this, by integrating our technologies with other streams of engineering also, we can do that. So it is very surprising to know that even Ganesh idols, they are brought from China, which is our god, but they can manufacture our idols of our god within less time with less price. Was it not surprising? It was really surprising. And it was stunning to us as an engineer. So can we now use all these techniques into our day-to-day working? Can we learn these techniques? Can we adopt? And can we change our attitude that how we can work on these techniques so that the time in which I am bringing a new product to the market can be reduced? The another thing, the features can be enhanced, the cost can be reduced. The major problem is the competition of the cost. Only why China, survives with all other countries is the cost. So yes, we have a lot of aspects that a mechanical engineer can think of, because finally the product can be of any field. It could be an electronic, it could be an IT, it could be a chemical engineering machine, but there is a mechanical engineer behind that who is designing, developing, and manufacturing a product. So ultimately, we are the person. We need to employ all these things into designing and manufacturing.
Okay, sir. One more question.
Yeah.
AI is also considered as a threat to human. So, if they become super intelligent, or is this just a fiction? On a lighter
See,
note.
this is a fiction what we have seen in basically Hollywood movies. So machine cannot be more intelligent than that, because we are the people those who are going to add intelligence into that. Let us take artificial intelligence. So when you say robot, we are going to program the robot that suppose there, if a robot is walking, if he is going towards a patient, say suppose like in case of COVID, now we have designed a trolley. Actually, it's not a robot; it's only a trolley which can move on four wheels. It can go nearer to the patient and supply some medicines or food. Okay, and it will come back. So we had some sensors fitted, line sensors basically, those have been fitted, some speed has been defined, and with a remote control you can do it. Okay, so it is we can decide what sort of intelligence we want to add into these artificial things. So I don't think that they will be more intelligent than a human being. Finally we are going to handle them. So when you say that they will superimpose us, they will supersede us, it's basically a fiction, and it is good to see in movies only.
And one more thing, a very practical thing. Nowadays, we are adapting generative design. Everyone
Yeah.
is adapting generative design. But what about the role of decision making? Like as an engineer, what is the role of decision making in this AI blended with CAD?
See, there are three aspects of this. One thing is that if you see Indian industry traditionally for last 40, 50 years, to be frank, we have not designed and developed so many things. We were doing reverse engineering actually. So we were copy pasting the existing products which were done by MNCs. The second thing is that either we had tie-ups like Maruti Suzuki. Okay. So we had a tie-up with Suzuki. The cars were designed developed by Suzuki, and the design came to India. We only manufactured it. Okay. So all intelligence was with them. And the third thing is that now we have started with what you call a generative engineering. R&D is our own. We are trying to generate our own designs. Okay. Like, the best example is Tata's, that they are coming with new cars. They are indigenously designed in India. So now when you want to go, you need tools and techniques which will help you to design and develop more and more good products, better products, to understand the customers. Because as I said, if you ask a question to you and me, what was my first mobile phone and what is my mobile phone right now I'm using, if it is third, fourth, fifth, or 10th, I have not stuck to the same company. Okay. So being a customer, I'm not loyal actually. Okay. I have changed my choices over the time. Now I'm using MI. Maybe now I will use something other. The first one was of Nokia. In between, I changed so many. So as a customer, I'm not loyal actually with the industry. And you know that once I purchase a mobile, definitely I will not go back to the industry to purchase a new mobile at least for 1 year. So that company, that manufacturer has lost me for 1 year. So when you see, when you are trying to design and develop new product, you also need to understand your customers, whether they are loyal or not, their likings are changing or not, what are their choices, what they want. And to understand that, you need to generate lot many data, and you need to handle this data. And when you want to process this data to understand and to come to conclusion and to take the decisions based on that, okay, you need all these techniques to be utilized. Otherwise, manually you can't do this. Then manually, what you can do, that based on intuition, you can say that could be your personal decision, personal intuition, personal experience, but it can't be the perspective from the point of data collect. Okay, because data is enormous, and if you want to process that, understand that, come to the conclusion based on that, okay, then you need to do all these techniques in manufacturing for decision making. It will help you in better fashion.
Okay, sir. And one more question. Okay. Students nowadays are debating from choosing the mechanical branch, but don't you think that the process of progress of computers, various tools like AI, big data, machine learning will benefit to the branch of mechanical engineering?
Definitely it will benefit to the branch of mechanical engineering. See, we cannot work in isolation now. These are the days of integration. Okay, so we already started mechatronics few years back, integration of mechanical and electronics engineering, and now we are working with not many technologies of computer science. We are working with electrical engineering, we are working with chemical engineering, we are working with material science. Unless and until you know materials, you can't do anything right now. And these integration and all these computer related technologies, those are coming right now, they are helpful to the mechanical engineers. Because you see, even their chips, their boards, their computer is being manufactured by we only. So if I'm using a laptop, though it is a IT gadget, okay, the body has been designed by me, the buttons has been designed by me, the spring below the button has been designed by me only. So I decide the reliability of the system. So being a mechanical engineer, being the creator actually, okay, we are interrelated with all other branch, and all these techniques are going to help us basically in making the decision making. So they will be definitely helping mechanical engineering to grow, okay, to explore basically, to expand basically.
Okay. So we had a wonderful question answer session. I really liked it. Now
Thank
I
you.
thank our expert, Professor Dr. G.M. Kakandikar sir. I thank Dr. Latesh Chaudhary sir, Principal of RNGPIT College, Dr. K.B. Rathod sir, Head of the Mechanical Department, Management of SVPES, for providing such a wonderful platform to spread knowledge across the globe. I also thank Professor Nirav Rathod sir, Professor Dharmin Patel sir, Professor Chirag Desai sir for their tireless effort in organizing this fourth webinar series. And last but not the least, I would thank all the participants, viewers, for grabbing this opportunity and participating in question answer sessions and improving your knowledge. Thank you very much.
Thank you. Thank you very much. It was nice talking to all of you. Thank you.